This lecture will cover the three types of studies used in psychological research. They are descriptive, correlational, and experimental. As you go down the list, the methods become more rigorous, and the conclusions or inferences we can make from them become stronger. All research involves variables, which are things in the world that can vary. As mentioned in the previous lecture on scientific method, many of the variables that psychologists study are constructs, internal states that are not directly observable and that require us to operationally define them. Descriptive studies, which are sometimes called observational studies, involve watching and recording behaviors. For example, going back to our topic of the frustration-aggression hypothesis from the previous lecture, we can conduct a descriptive study of children's aggressive behaviors on the playground. We could be systematic in our observations by dividing the playground into quadrants, and then use a stopwatch to spend time watching each quadrant and recording how many aggressive behaviors occur in that time. This could help us to generate hypotheses for which activities in the playground lead to more aggression. We could also break the observations down by gender. Then we would know which gender is being more aggressive, and if that aggression difference was different across the quadrant. So perhaps the boys are more aggressive near the slides, and the girls are more aggressive near the swings. One type of descriptive study is naturalistic observation. In this type of study, the researcher is a passive observer of the subjects in their normal environment. The researcher does not interact with the subjects to influence their behavior. An example of this is research on flirting, in which the researcher sits unobtrusively in a bar and records the behaviors of the other patrons as they interact with one another. A second type of descriptive study is participant observation. Unlike with naturalistic observation, the researcher becomes an active participant in the situation. For example, Leon Festinger and his colleagues noticed a rising number of doomsday cults after World War II, and were interested in what would happen to members of the cults once the prophesied date of the end of the world came and passed without the world ending. They each joined a cult and observed the activities of the member as the day came closer and closer. Interestingly, they found that even when the day passed and the world was still here, many of the members, rather than being disillusioned, became even more dedicated to the cult. This observation led Festinger to develop the theory of cognitive dissonance, which we will cover in a chapter on social psychology. One possible problem with this type of research is that the objectivity of the observer may be weakened. They may also unintentionally change the behavior of the subjects by interacting with them. Sometimes a study is an in-depth examination of a single individual or a single group. These types of studies are known as case studies. An example of a case study is the evaluation of Charles Manson in an attempt to understand the drives and motivations of murderers. There are a number of advantages of using descriptive methods to study human behavior. First, as discussed in the lecture on scientific method, they are great to generate hypotheses about why people do the things they do. Second, there is no bias in self-report. Many of the things that we want to study, people might not answer honestly about. This could be due to a desire to appear in a positive light, or they might not know how they actually feel, or why they do the things they do. Since observation looks at only external behaviors rather than internal states, there's no editing of the response for the researcher. However, there are a number of weaknesses with descriptive methods. First, there's low external validity. We will discuss external validity in more detail in the next lecture, but simply, it is the ability to generalize the findings of our study to different people, locations, or situations, which for descriptive studies is very low. For example, the findings of child aggression on a single playground cannot be generalized to other children on other playgrounds. Another weakness is observer bias, which are systematic errors in observation because of the expectations of the observer. For example, if the researcher's expectation is that boys are more aggressive, they may interpret aggressive behaviors in girls as something else, thus creating bias in the results. Finally, some behaviors are not observable, either due to infrequency of occurrence or the ethics of observing them. For example, it would be unethical to use natural observation to observe sexual behaviors. We will talk more about ethics in the next lecture. Correlational studies are the second major type of research study. Correlational studies examine how variables relate to one another, without attempting to manipulate either one of them. Correlational studies allow us to make predictions of where someone will fall on one variable by measuring another variable. For example, the reason colleges use SAT scores for admittance decisions is because scores on the SAT predict first-year college GPA. That is, the better a student does on the SAT, the higher his or her first-year GPA tends to be. Another example of a correlation is between height and weight. People that are taller tend to be heavier, and shorter people tend to weigh less. Neither the GPA-SAT or height-weight relationship is perfect. So you'll have some people who score poorly on the SAT who do well their first year of college. You'll also have some students that do well on the SAT who do poorly their first year. The strength of the relationship between the two variables is measured using the correlation coefficient. The strength of this relationship runs from -1 to 1, with 0 being no relationship, and the further towards the positive you go from 0, indicating a stronger positive relationship, and the closer you get to -1 being a stronger negative relationship. The direction and strength of a relationship are independent, meaning you can have two variables that are very strongly negatively related or very strongly positively related. Height and weight and GPA and SAT are both positive relationships, meaning that as people's score on one of these variables increases, their score on the other tends to increase as well. Negative correlation predicts that as a score on one variable increases, the score on the second tends to decrease. Using country as our unit of measure rather than individual people, the higher a country's vaccination rate, the lower the rate of disease in that country. Another example of a negative correlation would be depression and life satisfaction. The higher an individual's depression score, the less life satisfaction they tend to have. Correlational analyses are often shown in graphical form using a scatter plot. A scatter plot creates an individual point for each person at the intersection of their score on the two variables. The correlation coefficient is the best fitting line between all the points and is often presented in the scatter plot as well. This example shows a perfect positive correlation in which each point is directly in line of the correlation coefficient. Perfect correlations are extremely rare and are often only found when you are measuring the same variable using different scales. For example, measuring height using inches and centimeters will result in a perfect positive correlation. Here are some other examples of scatter plots. The one on the left is another positive correlation, this one showing SAT scores and first-year GPA. Though not perfect, as you can see, the best fitting line, which is the correlation coefficient, does not pass directly through each point. However, the trend is positive. The middle scatter plot is an example of no relationship, which has a correlation coefficient close to 0. This example shows that the number of pets someone has does not predict the number of credits they will take their first term in college. The scatter plot to the right is an example of a negative correlation. As you can see, as the value for depression score increases on the x-axis, the scores on life satisfaction, which are on the y-axis, decreases. The correlation between ice cream sales and murder rates in New York City is 0.7. This is a pretty strong positive correlation. Thus, as ice cream sales increase, the rate of murder also increases. Why do they correlate so highly? Do people in New York go on sugar-fueled murder sprees due to ice cream? That is, do increases in ice cream cause more murder? Or do murderers celebrate with a delicious ice cream? That is, does the increase in murder cause more sales of ice cream? What do you think? This doesn't seem reasonable. The likely answer is no. What is more likely to be causing both of these increases is the third variable of temperature. As temperatures increase, people tend to buy more ice cream. Additionally, as temperatures increase, so do murder rates, due to a number of factors, such as people are out more often, more windows are being left open, and frustration increasing more in the hot summer months. This should warn you that even though two variables are correlated, it does not mean there has to be a causal relationship between them. There are a number of reasons you could find a correlation between variables other than the directional causation you expect. First, as we saw, there could be a third variable, such as temperature causing an increase in both your variables, ice cream sales and murder rates. Another example of this is the correlation between height and math ability. This doesn't mean that taller people are better at math, but rather age leads kids to grow taller as well as have increases in math ability. The second reason is the direction of the causal relationship could run in an opposite direction to what you expect. Rather than variable x causing changes in variable y, it could be variable y causing changes in variable x. Finally, the relationship between the two you found in your study could be spurious, that is, due to chance. As another example of this, let's look at the negative correlation between depression and self-esteem. It could be that low self-esteem causes higher depression. It could also be that depression causes lower self-esteem. It could also be that a third variable, such as a distressing event, for example being dumped by a significant other or being fired from a job, leads to a decrease in both self-esteem and depression. So, again, just because there is a correlation between two variables does not always equate to causation. In order to make causal inferences, we need to do an experiment, which we will discuss shortly. One of the most common methods of conducting correlational research is to use a survey. Surveys have individuals complete questions about themselves such as, how happy are you currently? How much money do you make monthly? How many close friends do you have? The relationship between these items could then be used to evaluate the correlations. For example, does the amount of money someone makes predict their happiness? Or does the number of close friends positively correlate with happiness? Generally, researchers want to make statements of the relationship between the variables beyond just the people they collect the data from. That is, they want external validity. They want to generalize to a population of individuals. A population is the total set of individuals the researcher wants to study. For example, I may want to study the relationship between life satisfaction and number of friends for the whole University of Oregon student body. Or I may want to look at the relationship between stress and performance of students in this class. However, I may not want to have to collect data from all the university students or all the students in this class. In that case, I will collect data from a subset of the population, known as a sample. For example, to examine the link between friends and life satisfaction of University of Oregon students, I could just ask the students in this class the questions. If I was interested in the correlation between stress and performance of the students only in this class, I could select 10 students and give them a stress assessment at the beginning of the course, and then run a correlation between those scores and their final average in the class. Both of these examples use samples to make inferences about the population. However, the method that we use to select our sample can impact the strength of those inferences. The best method to select the sample to make the strongest generalizations to the population is random sampling. This is a method that allows each member of the population an equal likelihood of being part of the sample. For example, if I wanted to study the relationship between number of friends and happiness in the whole population of University of Oregon students, I could randomly draw 200 student ID numbers and send the questionnaire to those students. If they all completed the assessment, it is likely that that sample reflects the characteristics of the population of University of Oregon students as a whole. Of course, in the real world, not all the students would complete the assessment. This could lead to selection bias, which is an unintended difference between those who choose to complete the assessment and those who do not. If only 100 students completed the assessment, it could be that these students are more extroverted than the others. Thus, the population I'm actually studying is not all University of Oregon students. It may just be the extroverted University of Oregon students. There are good things about correlational studies. Unlike with descriptive studies, you can ask your participants the questions you want to know the answers to, so you're not relying just on behaviors. You can also select the population you're interested in. However, there are issues. People may give you the answer you want to hear, or the answer that is socially desirable, thus biasing the results. For example, early research on stereotype and prejudice was conducted by just asking people their attitudes towards outgroup members. In the 1920s to the 1950s, this method worked. However, in the 1960s, responses on these questionnaires demonstrated a marked decrease in racial prejudice. However, this was not due to a rapid decrease in these attitudes, but rather changes in society leading to expressions of racial prejudice becoming more socially undesirable. Another issue with correlational research is whether the sample represents the population. As discussed, the best way to deal with this is to randomly sample from the population. However, this is not always possible. In fact, the most studied population of people are first-year psychology majors. Often the findings from this group are generalized to the broad population of Americans, and often even more broadly to the whole world. True random samples are difficult to obtain, so the degree of generalization is often not as strong as researchers would like. Often we rely on convenience samples, which are the people that are most easily available to us or want to take part in our studies. The gold standard of research is the experiment. Experimental design allows us to explore the cause and effect relationship of variables. In experiments, we manipulate one or more of the variables of interest while keeping everything else the same, or controlling other factors. By manipulating the factors we think of as the cause for behavior, and then measuring the differences in the effect, we can evaluate these cause and effect relationships. The variable we think is the cause is called the independent variable. This is the variable that is manipulated in the study. The variable that is the effect is known as the dependent variable because it depends on the causal variable. The dependent variable is measured. In the lecture on scientific method, I discussed the study that evaluated whether frustration led to increases in aggression in students. Frustration was the independent variable and was manipulated by the students either having to wait to play with the toys or getting instant access. The dependent variable was the number of aggressive acts that students engaged in once they had access to the toys. The researchers found that students made to wait were more aggressive. Since the frustration manipulation was the only thing that differed between the students, the differences in aggression were caused by the manipulation in frustration. Now, the ability to make the cause and effect statement requires that the only thing to differ between the groups is the manipulated variable. However, people vary on many individual differences. For example, students vary in how aggressive they normally are, how patient they are, on moods, intelligence, and many other factors. So how do we assure the independent variable is the only factor that differs between the groups? One method is through random assignment. This is the process by which all members of the sample have an equal chance to be in either group. The students in the frustration study were randomly assigned to either the frustrated or not frustrated group. Thus, the individual differences that exist should be balanced out in the two groups. The power of random assignment to result in equivalent groups depends on the size of the sample, with more participants in each group increasing the likelihood of balanced groups. Random assignment, therefore, decreases the likelihood of confounds, which are anything that can affect the independent variable and that differ systematically between the two groups. For example, if the students in the frustrated group were all brought to the toy room right before lunch, and the students in the not frustrated group were brought after lunch, the increase in aggression may have been due to hunger rather than frustration. That is, the effect of frustration on aggression would have been confounded by the possible effect of hunger. Therefore, the researcher used experimental control to ensure the only difference between the groups is the manipulation of the independent variable. Let's test your understanding of the principles of experimentation using a study conducted by Phil Zimbardo. Zimbardo found while reviewing historical accounts that people who were anonymous engaged in more antisocial behavior than those who were identified. For example, he found that when members of the Ku Klux Klan were in fully hooded and anonymous regalia, they engaged in more aggressive actions towards African Americans than when identifiable. These behaviors included increases in physical abuse, cross burnings, and lynchings. Zimbardo then developed an experiment to test the hypothesis that anonymity caused more antisocial behavior. To do so, he randomly assigned female college students to wear either their own clothes with a name tag or a hooded outfit in which they couldn't be identified. They then were given the task of shocking a student in another room. What do you think he found? He found that the anonymous group gave significantly more shocks to the student in the other room, who in fact was a confederate of the experimenter and was not actually shocked. The anonymous group also gave longer shocks than the identifiable group. What was the independent variable? It was whether the student was anonymous or not, which was operationally defined as either wearing their own clothes with a name tag or in a hooded outfit. What was the dependent variable? It was antisocial behaviors, which was operationally defined as the amount and duration of the shocks given to the other student. We have now covered the three major types of psychological studies. Under each of these types are myriad different iterations. Descriptive studies are good for generating hypotheses and seeing how people behave in their normal environment. However, they can explain behavior or demonstrate relationships between variables. Correlational studies can describe relationships, helping us to make predictions. Experiments allow us to make causal statements to explain behavior. The next lecture will discuss additional considerations in research studies, including data analysis and ethics.